In order to find force, we have the equation work equals force times distance. But because we don't have the force yet, we have to use force equals mass times acceleration. So, the mass of the running back is 92 kilograms. And now we have to multiply that by the acceleration, which is 7.2. Now we're going to plug this into our calculator. 92 times 7.2 equals 662.4. So that is now our force. So now that we have our force, we can plug this into our equation. So work equals 662.4 times our distance, which is 37 meters. Now we can plug this back into our calculator. 662.4 times 37. Now our work is 24,508.8. In order to find the work of the linebacker, we have to do the equation work equals force times distance. But because we don't have our force, we have to use this equation, force equals mass times acceleration, to plug this in. So, we're going to take the mass of the linebacker, which is 109 kilograms, and multiply that by the acceleration, which is 4.6. Now we go in here and we plug in into our calculator. 109 times 4.6. So now we have our force of 501.4. So we take this number and we plug it back into our equation. So work equals 501.4 times the distance, which is 12 meters. Now that we have an equation, we can plug this into our calculator. 501.4 times 12, which equals 16.8 joules.
Go. In order to find kinetic energy for the running back, this is your formula. Kinetic energy equals 1/2 mass velocity squared. So, we're gonna put 1/2. The mass of the running back is 92 kilograms, and the velocity is 9.66 squared. Make sure you square it. So we're gonna get our calculator right here. Handy dandy Texas Instruments. We're gonna put 1/2 times 92 times 9.66 squared. And that's our answer. 42. What? Oh, sorry. Guys. I'm a little nervous. This is our answer. I don't know how to say the word. It's pretty big, but there we go. So now we're gonna find the kinetic energy for the linebacker this time. We're gonna do the same formula, but just different numbers. So we're gonna do 1/2. The mass of the linebacker is 109 kilograms. And the velocity is 8.2. We're gonna grab our same calculator and put it in here. Oh, square. Skirt. Don't be like me. Okay. 1 times divided by, you know what? Times 109 times 8.2 squared. And it gave us this big number that I can't say. There we go. Thank you.
Today we're going to be finding the potential energy of the running back. So the formula is potential energy equals mass times gravity times height. So we're going to take the mass of the running back, which is 92 kilograms, multiply that by gravity, which is always 9.8, and then the height at which he jumped, which is, what is it?
1.3.
1.3. Now we're going to plug this into our calculator. 92 times 9.8 times 1.3. So our answer is 1,172.08. Hi everyone, so today we're going to be calculating the potential energy of the linebacker. So our equation is potential energy equals mass times gravity times height. So we're going to take the mass of the linebacker, which is 109 kilograms, and multiply that by gravity, which is always 9.8. Then we're going to multiply all of this by the height at which he jumped, which is 0.4 meters. So now we're going to go in and plug this into our calculator. 109 times 9.8 times 0.4, which is, we get our answer 427.28.
In order to find work energy theorem, you have to use the formula work equals force times distance. And so we're going to plug in our kinetic energy for the running back for work, which was a big word.
4,292.5
equals force, which we don't know, so we're looking for. And then our distance for the running back was 3. So in order to find that, you gotta move the 3 over here to get the F by itself. So divide by 3 on both sides. That cancels out. And then you divide these two. Using this handy dandy calculator. 2.5 divided by 3, and that gives you
1,430.8. Yay.
That's our answer. So now we're gonna do work energy theorem for the linebacker. So we're gonna use the same formula, work equals force times distance, but we're gonna we're gonna use kinetic energy for work instead. So here we go. Oh, sorry. My bad. Thank you. This is right here, the kinetic energy for the linebacker that I'm writing down. It's a big word, can't say it.
3,664.5.
Thank you. And we're trying to find force. So F right here, and then the distance for it was 2. The distance for the linebacker was 2. And so we're gonna do the same thing we did before, is we're gonna move 2 over here, so F will be by itself. And then that cancels out. So now you just calculate it.
It's been a long day.
Divided by 2.
1,832.25.
Thanks, Emily. 0.25. You can round whatever, but I don't know how to do that. There we go. Thank you.
Okay, so today we're going to be finding the power of the running back. So the formula is power equals work divided by time. So we're going to take our work, which is 2,508.8 to 24,508.8, and divide that by the time, which is 1.34. Then I'm going to take my calculator and plug this in. 24,508.8 divided by 1.34. And now we're going to get our answer, which is 18,290.15. Today we're going to be finding the power of the linebacker. So our equation is power equals work divided by time. So we're going to take the work of the linebacker, which is 6,016.8, and divide that by the time, which is 1.78. Now we're going to plug this into our calculator. 6,016.8 divided by 1.78.
Oh, the battery was going low. So we have backup. Sorry.
Yep, you should always have 2 calculators on hand. All right, so 6,016.8 divided by 1.78. That gives us 3,380.22. Alright, so in order to find force, the equation is work equals force times distance. But you need to find your force. So the equation for force is force equals mass times acceleration. So in order to find the running back's work, we need to find force. So we're going to take their mass, which is 92 kilograms, and multiply that by 7.2 millisecond, or whatever it is, squared. Alright, so we're gonna plug this into our calculator. 92 times 7.2. Wait, do I have to square it?
Yes, it's squared.
Never mind. So you're gonna do 7.2. Wait, start over because I can't square. Okay, in order to find work, the equation is work equals force times distance. But first, we need to find the force because that's the thing that we don't have. So the force equation is force equals mass times acceleration. So the mass of the running back is 92 kilograms. So we're going to multiply that by the acceleration, which is 7.2. So we're going to plug this into our calculator. Oh. We're going to plug this into our calculator. If it'll turn on. You know what? I don't know what happened.
Let's do it again.
Go.
Hello. In order to find work energy theorem, you have to do the formula work equals force times Matt?